So we're going to start trying to take the reference angle from one part of the circle and find the angle in standard position on the other side. Now the key thing here is the reference angle is the same for all four terminal sides. So what we need to do is, if this is 30 degrees, like all of these, what is the angle in standard position to this terminal line? So we know that this whole part is 180. We're short by 30, so we're going to subtract to get 150. 180 minus 30. This one here we go past 180, so we're going to do 180 plus 30. And this one here we use 360. We always use the 180 or 360, whatever's closest to the terminal side. And so 360 minus 30, 330 degrees. All four of these angles are in standard position and they all have the same reference angle. That's what we're trying to do. We're trying to take one angle and duplicate it, reflect it on the other side of the y-axis. So pause the video. Try this one on your own. We've got 70 degrees and we're trying to find the other three in standard position. So pause the video, then play it once you're done. So 70 degrees is the reference angle. So to find this one, we've got to take 180 minus the 70. This one's 180 plus 70. And 360 minus 70. Notice that we only use the x-axis, the 0, 360, and 180. Now we have four angles. They're all in standard position. They all have the same reference angle. So try this one on your own. It has an extra step. Pause the video and then play it once you get stuck. So this one, we're not given the reference angle. We're not given the quadrant 1 standard position. So we have to take this and we need to find the reference angle by subtracting. 215 minus 180, 35 degrees. Now 35 degrees will be the angle on the other side. It's a reference angle and standard position. Now we have to find quadrant 2, quadrant 4. 180 minus 35 and 360 minus 35. Now we have all four angles. Oops, not that one, this one. So four angles, they all have the same reference angle. That's our goal. We're taking one and reflecting it up and over. Before we move on to the next example, I want to show that if we take a point and if it's on the circle, let's take the example 2, 3. Over 2, up 3. And if I go straight across till I hit the circle, it's going to be almost the same points. The only thing though is the x-coordinate is now negative. The y-coordinate is the same when you travel sideways, horizontally. The x-coordinate will switch to a negative. If I go straight down, they will both be negative. So the x has remained the same, the y changes to negative. And back over here, the x becomes positive, but the y stays the same. So if we go sideways, the y stays the same. If we go vertically, the x stays the same. Key thing. So if we sideways, the y stays the same. Up and down, x stays the same. So we're going to do the same thing. We're going to take a reference angle and move it to other places on the circle with the same reference angle. Now one extra thing we're going to do, same reference angle, but we also want the y-coordinate to stay the same. Now in the last example we saw if we go sideways over here, the y-coordinate will stay the same. The x will change, it'll become negative, but the y will remain the same. So our goal is to find the standard position angle of this point. We know it's going to be a reference angle of 45. We know this is 180. So to find this one, 180 minus 45 135 degrees. 45 and 135, they have the same reference angle, they have the same y coordinate, same height. That's our goal. How do we take it to the next quadrant? Keeping the same coordinate, the same reference angle. So same type of question, but slightly different. We want the same reference angle. So it could be here, could be down. This time we want the same x coordinate. So we learned that up and down, the x stays the same. If I move across, it becomes negative. If I go straight down, it stays positive. So I need to go straight down and keep the same reference angle. So I know this is 360 up here, 70. So I'm going to subtract them and get 290. The reference angle is the same. The x coordinate is the same. Try the next two in the notes. Pause the video and then check your answers once you're done. So this time we're going to do another one where the x is the same. So if I go across, the x becomes positive. Don't want that. I want to go straight down. Now I need the reference angle to figure out this angle. So if this is 160, 180 minus 160 is 20. And then I have to do 180 plus 20, 200. Same x coordinate, same reference angle. Try the next one, pause the video. So this time we're starting with 240 degrees and we want the same y coordinate. Again, if I move up here, it becomes positive, so I don't want to do that. Same y is straight across. Now, I need the reference angle, so 240 minus 180 is 60. So I need to take this over here and switch to 360. 360 minus 60 is 300 degrees. So find the reference angle, figure out which way we're going, and then use that reference angle to find the new angle. This one is straight across, same y coordinate, same reference angle. So try the questions in the notes package, and that's it.